In this lecture, let's first understand what exactly is a state machine. We also call it as an FSM, Finite State Machine. A state machine is a software computation model. It's just a model to solve a complex application, and it comprises of finite number of states, hence it is also called as finite state machine. So states are nothing but situations of your application, different situations. Since states are finite, there is a finite number of transitions among the states. The transitions are triggered by the incidents, or what we call as input events, fed to the state machine. Basically, an FSM is an event-driven reactive system. So we will understand more on this later about states and transitions and what exactly are events, etc. We are going to discuss a lot of things about these terminologies with various examples. A state machine also produces an output. The output produced depends on the current state of the state machine sometimes, and sometimes it also depends on the input events fed to the state machine. So here is an example. Here you are seeing a flat state machine. There are different types of state machines like flat state machines, hierarchical state machines, and various other things. So we will discuss all those things later, but just to you the feel of an FSM, here you can see that there are various states which are interconnected, right? And these states, they represent different situations of the application or the problem what you need to solve. This situation is represented as a state in the state machine diagram which handles different events, and it may produce different outputs. And you see here there are various interconnections between these states. These are called as transitions, and transitions are caused because of an event which is received by the state machine. Since the application moves between different states, producing various outputs and processing various events, this may be called as a machine, a state machine. So we will see how to draw these diagrams later. Basically, this is drawn using the syntax of UML state machine specification, and we'll be using the UML specification throughout this course. Now let's get back to our lecture. What are the benefits of using state machines? State machines are used to describe situations, as I explained, or different scenarios of your application, or to be precisely, state machine models different scenarios of the application object. Objects in OOP terminology, that is object-oriented terminology, is nothing but an instance of a class or an instance of a structure in C. So application may be having different classes. So a state machine actually belongs to a class. If your application has many classes, then there could be many state machines. Not necessarily life cycle of every class has to be modeled by means of a state machine. So FSMs are helpful in modeling the life cycle of a reactive object through interconnections of states. Here, object is nothing but an instance of a class. And FSMs are helpful to model complex applications that involve lots of decision making, producing different outputs, and processing various events. So many times overwhelmed by the complexity of the application receives various asynchronous events, various synchronous events, interrupts, and the application looks very tedious because it produces various outputs. And when this event is received, that action should be taken, and when that action happens, this event should be produced. All these things which are in your mind, you can express it through the state machine diagrams, what we call as state charts, and it will help you to visualize the problem more clearly, and you can decompose the complexity, or you can narrow down the complexity to state level complexity, and you can address the problem with much more clarity, and you can work efficiently. So that's one of the biggest advantage of using FSMs, that it helps you to decompose your complex application into smaller situations, and you can think about solving just that situation, and then you interconnect all the situations to finally solve your problem. And state machines are visualized through state machine diagrams in the form of state charts. This helps to communicate between non-developers and developers. That is one of the advantages of expressing finite state machines in the form of diagrams. FSM makes it easier to visualize and implement the changes to the behavior of the project. Tomorrow, if you want to incorporate any other changes or if you want to add any new features, then it is very easy or straightforward to make changes to the existing FSM diagram. Complex application can be visualized as a collection of different states, each state processing a fixed set of events and producing fixed set of outputs. Loose coupling. An application can be divided into multiple state machines and each unit can be tested separately or could be reused in other applications. Easy debugging. This is also one of the advantages of solving a problem using FSM. Scalable, and troubleshooting becomes much more easier than implementing the same problem using traditional procedure based step-by-step implementation, what we have been doing so far. So later when we implement some applications, you will definitely appreciate the idea of finite state machines. Now let's move forward. There are different types of state machines. First one is Mealy machine, Moo machine, Hurrell state charts, and UML state machines. Some of these state machines are used for software engineering and some state machines are still being used in digital electronics, VLSI design, etc. In this course, we are interested in UML state machines because this state machine is predominantly used in software engineering to model the software engineering problems, and it is influenced by David Hurrell's state chart formalism explained by this research paper which was published in 1980s. And in the market, there are various tools available which can interpret your UML state charts and it can generate the base level code. So that's the advantage of using UML specification based state machine diagrams. You can auto generate the code in C or C++ or Java using some of these tools. So these are the tools from IBM, IAR, Quantum Leaps, and there is one more tool called Yakindu state chart tool. Some are paid tools and some are open source. So these tools can interpret your model and it can auto generate the code. In later part of the course, we will be using Quantum Leaps QP framework and QM modeler tool to implement nested hierarchical state machines. From the next lecture onwards, let's explore what exactly is a Mealy machine, how it is different from Moo machine, and we'll also explore the UML specification about drawing the UML state machines. I will see you in the next lecture.